Yuki. Welcome back to the IoT Programming course. This course is based on the book IoT Programming with MaTouch ESP32S3 1.28 touch. The goal of this course is to help you quickly learn the basic development of IoT applications based MaTouch 1.28 touchless controllers. In this lesson, we will learn how to make your MaTouch communicate with a web page through two essential web technologies, WebServers and WebSockets. Now, let's start with WebServers. So, what is WebServers? A web server is basically an HTTP-based service that listens for requests from clients, like your phones or computers, and sends back web pages or data in response. In short, it will allow your web page to display information and interact with the hardware. The ESP32 has a built-in Wi-Fi module, which makes it can act either as a Wi-Fi access point or as a system connecting to an external router. Once it gets an IP address, other devices, like your laptop or phones, can send HTTP requests directly to it. On the ESP32, we can store web files such as HTML, CSS, and JavaScript in speed or little less fast. And if you need more space, you can also use an SD card. When the HTTP server is running, it continuously listens for client requests, read the responding file from storage, and send them back as HTTP response, just like a mini web server running inside your ESP32. Okay, let's learn how the ESP32 can act as a web server to control LED from the web page. Connect the wire according to the wiring diagram below. By scanning the QR codes in the book, you can download all the example codes used in this course and send them to your computer. Open the file WebServers. Modify your Wi-Fi information according to your network environment. Create a WebServers object listening on port 80, which is the sender point for HTTP communication. In the setup function, connect to the Wi-Fi. Register URL routing. Different URLs correspond to different handles function. Handle root, handle LED on, handle LED off. The handle root function builds the main web page dynamically. It changes color and text based on the LED state. When the LED is on, the button turns red and so turns off. When the LED is off, the button turns green and so turns on. Use simple HTML and CSS to define a web page, including elements, styles, titles, buttons, and so on. Send HTTP response. The handle LED on and handle LED off functions control the LED pin directly. Update the display with the LED current data, and then redirect the user base to the main page using an HTTP 3002 response. Start the web servers on the ESP32. Display IP address and LED state on the screen. In the root function, we call server handle clients to continuously listen for incoming HTTP requests from clients. With that, the code portion is complete. Use Type-C USB cable to connect the board and PC. And click the top menu. Then, select ESP32S3 stats models on the board. Choose the collect point, and set USB CDC on book to enable. Click the Upload button on the Arduino IDE and wait for the code to upload. Now, you can open a browser on your phones or computers, enter the IP address, and control the LED on or off remotely. Next, let's look at the WebSocket. So, what is WebSocket? WebSocket is a TCP-based full-duplex communications protocol that enable a persistent connection between a client and a server. With just a single handshake, it establishes a continuous two-way communications channel, allowing both the client and server to actively send data, providing store real-time capability. What is the difference between WebServer and WebSocket? The main difference between WebServer and WebSocket lies in their communication style. WebServers work in request-response, stateless, and one-way manner, making it suitable for control page or configuration tasks. WebSocket establishes a persistent, stable, and two-way connections, along with real-time, low-overhead data exchange, ideal for list monitoring, chat, or sensor data updates. Okay, let's explore how to use WebSocket for real-time monitoring of temperatures and humidity data. Connect the wire according to the wiring diagram below. Open the file WebSocket. Change your Wi-Fi information. Create an HTTP object that listens on port 18 for returning HTML page. The WebSocket servers listen on port 18.1 for real-time bidirectional communications between browser and the ESP32. Initialize the DHT sensor. We first see the setup function. Connect to Wi-Fi. Start the DHT sensor. Show the device IP address on the screen. Start the HTTP and WebSocket server. Within the root function, check for client connections. If there is a client request, return HTML page to the client. Within the HTML page function, define the structure of the web page and make it look nicer. Establish a WebSocket connection and update the data in real time. Handle WebSocket communication. Read temperature and humidity data. Update the data every second. With that, the code portion is complete. Use Type-C USB cable to connect the board and PCs. And click the top menu. Then, select ESP32S3 test models under book. Choose the collect point, and set USB CDC on book to enable. Click the Upload button on the Arduino IDE and wait for the code to upload. When the temperature or humidity changes, the page will update in real time. To better construct the WebServer and WebSocket, I implemented the same functionality using WebServer. WebSocket will actively pass the latest temperatures and humidity readings to all connected clients after each read, while the WebServers only update the data after a refresh. Congratulations on completing Lesson 6. Hope you enjoy it. Bye!